Hello future aspirants, welcome back to our channel. Today we have here a very interesting problem of integration, that is integration of root over tan x dx. This is a problem which is approached by different people in a variety of way. But in the process people often complicate it and most of the students cannot understand the process. So I have come here with one of the most easiest solution for this problem. So without further ado, let's get started. So here we have the question, that is root over tan x dx. So what we have done here is that we have added and subtracted a root over cot x by 2. So what we have done here is that we have added and subtracted a root over cot x root over cot x by 2, and after that we write tan x root over tan x as root over tan x by 2 and root over tan x by 2, and then we arrange it in the following way. Now we break tan x into sin x by cos x and cot x as cos x by sin x, and we do the same thing over here. Now we cross multiply here, so the equation turns out to be as sin x plus cos x by 2 root over sin x cos x, and here if we cross multiply it turns out to be sin x minus cos x by 2 root over sin x cos x. So now we will use a substitution that is same for both the side but with different variables. So here we write sin x cos x as t square, and here sin x cos x as u square. After we apply UV rule here, we get the derivative of sin x cos x as cos square x minus sin square x dx, and on the other side we get 2t dt. Now cos square x minus sin square x can be written as cos x plus sin x into cos x minus sin x. So here we divide this by cos x minus sin x. So here the cos x minus sin x gets cancelled out, and here in the denominator we get a cos x minus sin x. We do the same thing for the other side, but here we divide the equation by cos x plus sin x. So why this change? Because here in the numerator we have sin x plus cos x dx, and on the other side we have sin x minus cos x. So that is why we have divided the derivative by cos x minus sin x and cos x plus sin x on the respective sides. Now we can write cos x minus sin x as root over cos square x plus sin square x minus 2 sin x cos x. This is the simple formula of a minus b is equals to root over a square plus b square minus 2ab. We do the same thing for the other side, but on this side we write a plus b is equals to root over a square plus b square plus 2ab. Now cos square x sin square x turns out to be 1, and the minus 2 sin x cos x turns out to be 2t square, because we have taken sin x cos x as t square. On the other side, the 2 sin x cos x plus 2 sin x cos x turns out to be as 2u square. So I guess this was clear. Now the rest of the sum is pretty simple. We just substitute here cos x minus sin x with root over 1 minus 2t square, and on the other side by 1 plus 2u square. Here we have made a slight adjustment because here we have sin x minus cos x. That is why we have divided it, or rather than multiplied both the sides by a minus. That is why here we get a minus sign. Now after substituting we get sin x plus cos x dx by 2 root over sin x cos x as 2t dt by root over 1 minus 2t square. This was from here. We have substituted this part, and the denominator, that is 2 root over sin x cos x, turns out to be as 2t. The same is for the other side. Here this turns out to be 2u minus 2u du by root over 1 plus 2u square, and we cancel out the 2u and on the other side the 2t. Now from the denominator inside the root we take a 2 common. So when 2 comes out of the root, it turns out to be as root 2. So we have done this on the both the sides. I repeat what we have done. We have taken a 2 common, and when it comes out of the 2, it turns out to be as root 2. We have done this on both the sides, and now we have applied the simple formula of derivative. On this side we have applied the formula that is dx by root over a square minus x square, which is equals to sine inverse x by a. We have applied this formula here, and on this side we have applied the formula of root over dx x by a square plus x square is equals to ln x plus root over a square plus x square. We have applied both the formulas on the respective side. Here the term which is a square is 1 by root 2, and on here it is also 1 by root 2. So after putting the values here, we get this equation. But we need to remember that we have substituted t and u. We need to also put their original value. After putting their original value, we get this and this on the respective side. Because here we see that t square was sin x cos x. Therefore t must be equals to sin x cos x root over. We have done this for both the side, and this is our final answer. If you had any problem regarding the understanding of this solution, please do comment down. And if you liked the video and you thought that the solution was pretty simple compared to the rest, please do subscribe and share with your friends. Thank you.